Good morning, children. The last class we were discussing about what is a polynomial, what is the zero of a polynomial, and the different types of questions. Find the value of the polynomial at a given value of the variable, as well as check whether a given value of the variable is a zero or not. The next topic in this lesson is remainder theorem. The next topic is remainder theorem. Let's take a quick review on multiples and factors in the arithmetic system. Consider a number 12. What are the multiples of 12? How do you calculate the multiples of 12 as 12 ones are 12, 12 twos are 24, 12 threes are 36 and so on. Thus, 12, 24, 36 etc. are the multiples of 12. You were calculating, find the 8th multiple of 12 as the 8th multiple as 12 into 8 is equal to 96. Thus, any number is given to you, you can calculate the multiples. The same number 12, how do you find the factors of 12? The factors of 12, 1 into 12 gives you 12, 2 into 6 gives you 12, 3 into 4 also gives you 12. That is, the product of two numbers which is giving you 12, those two numbers were called as the factors. Thus, 1, 2, 3, 4, 6 and 12 are all factors of 12. 1 is a factor of every number. The number itself is a factor of itself. So, certain properties also are defined based on multiples and factors. How can we say that 2 is a factor of 12? How can we say that 6 is a factor of 12? Yes. 12 divided by 2, 2 6's are 12 and the remainder became 0. So, on division, dividend divided by divisor, you are getting a quotient and a remainder. So, on division, if the remainder becomes 0, each of the numbers will be called as the factor. That is, the divisor as well as the quotient will be a factor of the dividend. Or in the topic under our consideration is, can we divide a polynomial by another polynomial? And what can be the possible remainders? Let's take the example of a polynomial p of x as 3x cubed plus 2x square plus 7x and another polynomial g of x as x. We wanted to check whether the polynomial p of x can be divided by another polynomial g of x. As normal concept, 3x cubed plus 2x square plus 7x divided by x. That is, each term will have to be divided. 3x cubed by x plus 2x square by x plus 7x by x, and we are getting the calculation as 3x square plus 2x plus 7, that is, on dividing 3x cubed plus 2x square plus 7x by x, the quotient is 3x square plus 2x plus 0 and there is no remainder. Let us do this by a long division method. 3x cube plus 2x square plus 7x divided by x. 3x cube should be divided by x. The first, the quotient is 3x square. 3x square into x is 3x cubed. Let's subtract. We are getting this term getting cancelled. 2x square plus 7x. 2x square divided by x is giving you 2x. 2x square. You will change the sign and you will get the subtraction answer as 0. 7x. 7x divided by x is giving you 7. 7x and the remainder turned to be 0. That is, on dividing p of x 3x cube plus 2x square plus 7x by another polynomial g of x, the remainder is 0, which proves that g of x is a factor of p of x. G of x is a factor of p of x. Take the second example of p of x is equal to 4x raised to 4 plus 3x cube plus x square plus x plus 8 with the polynomial g of x is equal to x. By the first method, 4x raised to 4 plus 3x cube plus x square plus x plus 8, you are dividing with x. Each term 4x raised to 4 by x plus 3x cube by x plus x square by x plus x by x plus 8 by x. You are getting it as 4x cube, 3x square, x plus 1 plus 8 by x. Can you consider the term 8 by x belonging to the set of polynomials? No, because 8 by x will be 8x to the power of minus 1. Let's see what is happening to that term. Take the example of p of x is equal to x plus 3x square minus 1 and g of x is equal to 1 plus x. The previous two examples we were taking with a monomial x, and here we are taking the divisor as a binomial. The first step is to arrange both the polynomials in the standard form. What is the meaning of standard form is arrange the variables in the descending power of their descending power. That is, p of x has to be arranged as 3x square plus x minus 1 and g of x has to be arranged as x plus 1. The second step is to check whether the power of the variables are already in the descending power, that is, the variables have all the powers only in the dividend. You can see here the power of x is 2 and the power of x is 1. Arranging 3x square plus x minus 1 with x plus 1. The first step is to get the first term of the divisor, 3x square divided by x. You get it as 3x. The concept is you are multiplying this 3x with both the numbers. The first term is already calculated. The second term plus 1 into 3x is giving you plus 3x. Subtracting, we have to change the signs. 1x minus 3x is giving you minus 2x minus 1. This minus 1 is brought down. The next step is minus 2x divided by x is giving you minus 2. Minus 2 into x, as I told you, the first term you can write the same. plus 1 into minus 2 is minus 2. Again, subtraction means change the signs. Minus 1 plus 2 is plus 1. Since you got the remainder as plus 1, x plus 1 is not a factor of 3x square plus x minus 1. Another example of division. 3x raised to 4 minus 4x cube minus 3x minus 1 with the polynomial x minus 1. X raised to 4, x cube, x square term is missing. What you can do is, while arranging the dividend, 3x raised to 4 minus 4x cube plus 0x square minus 3x minus 1 divided by x minus 1. The first term, 3x raised to 4 by x is giving you 3x cube. 3x cube. 3x cube into x is giving you 3x raised to 4 minus 1 into 3x cube is giving you minus 3x cubed. You have to see that you are arranging under the like terms. Subtracting minus 4x cube plus 3x cube is giving you minus 1x cube plus 0x square minus 3x minus 1 minus 1x cubed divided by x is giving you minus x square. Minus x square into x, the first term you can write the same. Minus 1 into minus x square is giving you plus 1x square. You are changing the signs. 0x cube minus 1x square is minus 1x square minus 3x minus 1 minus 1x square by x is giving you minus 1x minus 1x square minus 1 into minus 1x is plus 1x. Changing. You are getting minus 4x minus 1 minus 4x divided by x is giving you minus 4 minus 4x minus 1 into minus 4 is plus 4 and you are getting the remainder as minus 5. Therefore, x minus 1 is not a factor of 3x raised to 4 minus 4x cube minus 3x minus 1 since the remainder is not 0. If you just revise the division done on these three polynomials by the corresponding polynomials, 3x square plus x minus 1 when divided by x plus 1, the remainder is 1. And we said x plus 1 is not a factor. Is not a factor. 3x raised to 4 minus 4x cube minus 3x minus 1 when divided by x minus 1. Remainder is minus 5 and we said that x minus 1 is not a factor. The third example, when x cubed plus 1 is divided by x plus 1, the remainder is 0 and thus we could say that x plus 1 is a factor. What is the meaning of x plus 1 is a factor is? X plus 1 divides the polynomial x cubed plus 1 and if we say x plus 1 is a factor, x plus 1 equal to 0, that is, the value of x is equal to minus 1 will make the polynomial x cube plus 1 a 0 polynomial. Equal to minus 1 is a 0 of the polynomial x cube plus 1, and by definition of the 0 of any polynomial is that value of the variable which makes the polynomial a 0 polynomial. If you substitute, you can see as minus 1 the whole cubed plus 1, minus 1 plus 1 is giving you 0. Thus, by all these divisions, how can we define remainder theorem? The remainder theorem is used to find the remainder of division by a polynomial by another polynomial, and the divisor should always be a linear polynomial. Let us discuss the meaning of remainder theorem, and then later on we will derive the statement. Remainder theorem states that let p of x be a polynomial of degree greater than or equal to 1. Let this polynomial be divided by another polynomial g of x of degree 1. Let it be of the form x minus a. Then what is the value of a is any real number. That is, a can be any number in the real number system. The remainder is the value of p of a. Without long division, you can get the value of the remainder as p of a. Why is it so? Is if x minus a is a factor, then x equal to a will be a 0 of that particular polynomial. So, the remainder will be easily got by substituting the value of x as a. After explanation, let me read the remainder theorem statement, textbook page 39. Let p of x be any polynomial of degree greater than or equal to 1, and let a be any real number. If p of x is divided by the linear polynomial x minus a, then the remainder is p of a. This is the statement in textbook page number 39. Please underline the statement. First, I will explain these two worked out examples in the textbook. I request my children to study these worked out examples, then do the exercise questions on your own and check the answers from my video. Find the remainder when x raised to 4 plus x cubed minus 2x square plus x plus 1 is divided by x minus 1. The presentation should be p of x is equal to x raised to 4 plus x cubed minus 2x square plus x plus 1. Remainder is equal to, if it is x minus 1, p of plus 1, which is equal to 1 to the power of 4 plus 1 cube minus 2 into 1 square plus 1 plus 1, which is equal to 1 to the power of 4 is 1 plus 1 minus 2 plus 1 plus 1. Add the positive numbers first. 1, 2, 3, 4. It is 4 minus 2, which is the same as 2. It is a 2-mark question for any exam. Similarly, check whether q of t is equal to 4t cube plus 4t square minus t minus 1 is a multiple of 2t plus 1. The matter is the same. If 2t plus 1 is a factor of this polynomial is a multiple. It is the same as q of t is equal to 4t cube plus 4t square minus t minus 1. 2t plus 1 equal to 0. 2t is equal to minus 1 or t is equal to minus half. When you substitute the value of t as minus half and if the remainder turns to be 0, it means that 2t plus 1 is a factor or the given polynomial is a multiple of the given is a multiple of 2t plus 1. T is equal to remainder is equal to 4 into minus 1 by 2 the whole cube plus 4 into minus 1 by 2 the whole square minus minus 1 by 2 minus 1. 4 into, to the odd power, it will be always negative. Minus 1 by 8 plus 4 into 1 by 2 to the power of negative 1 by 2 to the power of positive power. 2 is 1 by 4 plus minus and minus will become plus half minus 1. This can be cancelled. This can be cancelled. So, minus 1 by 2 plus 1 plus 1 by 2 minus 1 minus half and plus half gets cancelled. Plus 1 and minus 1 gets cancelled and it got as 0. Even if with LCM you can get a final answer. So, since the remainder is 0, 2t plus 1 is a factor or the given polynomial is a multiple. Since the remainder is 0, 4t cube plus 4t square minus t minus 1 is a multiple of 2t plus 1. This is the, I hope you have worked out on your own and you are checking only the answers. Find the remainder when p of x is equal to x cube plus 3x square plus 3x plus 1 is divided by x plus 1. Remainder is equal to p of minus 1, which is equal to minus 1 the whole cube, 3 into minus 1 square, 3 into minus 1 plus 1. If there is a negative base, if there are odd powers, it is negative value, and for even powers, it is positive value. Minus 1 square is positive 1, plus 3, minus 3 plus 1. Minus 1 and plus 1 gets cancelled, plus 3 and minus 3 gets cancelled. So the remainder is 0. The second question, remainder is equal to p of half, positive half, which is equal to 1 by 2 the whole cube plus 3 into 1 by 2 the whole square plus 3 into 1 by 2 plus 1, 1 by 8. 1 by 2 the whole square is 1 by 4, 3 by 4 plus 3 by 2 plus 1. The common LCM is 8. It is 1 plus 4 into 2. 6 plus 2 into 4. 12 plus 1 by 1, which shows that into 8 plus 8. So final answer 12 plus 8, 20. 21 plus 6, 27 by 8. The third one is with x. If you have, remembering my explanation with x, you can see the remainder is 1. But still, the remainder can be found out as p of 0. Since there is no negative 0, p of 0, because here it's understood that it is x plus 0, or it can be x minus 0. 0 plus 0 plus 0 plus 1, or the remainder turns to be 1. With x plus pi, the method remains the same. Remainder is equal to p of minus pi. It is minus pi the whole cubed plus 3 into minus pi square plus 3 into minus pi plus 1. The only measure is with the odd power, it is negative itself. So, minus pi cubed. Minus pi the whole square is positive pi square plus 3 pi square minus 3 pi plus 1. It cannot be simplified further. The remainder is this answer itself. And the fifth one, 5 plus 2x is the polynomial which has to be divided. Find out what is the value of x as 5 plus 2x is equal to 0 or 2x is equal to minus 5, x is equal to minus 5 by 2. That means you have to substitute the value of x as minus 5 by 2. That means you have to substitute the value of x as minus 5 by 2. P of minus 5 by 2. You are going to substitute and the remainder is P of minus 5 by 2. Minus 5 by 2 the whole cubed plus 3 into minus 5 by 2 the whole square plus 3 into minus 5 by 2 plus 1, which is the same as minus 125 by 8. 5 square is 25 by 4. 3 into 25 is 75 by 4. Minus 15 by 2 plus 1. LCM is 8. Minus 125 plus 150 minus 60 plus 8. Add the positive numbers, add the negative numbers, then you subtract. Minus 125 minus 60 is minus 185 plus 150 plus 8 is plus 158 by 8. Now you can subtract 8, 7 minus 27 by 8. If you further, it cannot be simplified. So the remainder is minus 27 by 8. Question number 2. Find the remainder when x cubed minus ax square plus 6x minus a is divided by x minus a. Remainder is equal to p of positive a, which is equal to a cube minus a into a square plus 6a minus a cube. A into a square is a cube plus 6a minus a. Positive a cube and negative a cube getting cancelled. 6a minus a is 5a. Therefore, the remainder is 5a. The last question, check whether 7 plus 3x is a factor of 3x cube plus 7x. 3x plus 7 is equal to 0. 3x is equal to minus 7 or x is equal to minus 7 by 3. Remainder is equal to p of minus 7 by 3, which is equal to 3 into minus 7 by 3 the whole cube plus 7 into minus 7 by 3. 3 into minus 243 by 3 cubed is 27 plus minus 49 by 3. 3 and 27 9 times. Minus 243 by 9 plus minus 49 by 3. LCM is 9. Minus 243 into 3 into 3. Minus 27, 147. From here itself you can infer it is not a factor because anyway the remainder is not going to be 0. But still you can present the answer 9 minus 390 by 9 divisible by 3 minus 130 by 3. How do you present the answer? Since remainder is not 0, is not 0. 7 plus 3x is not a factor of 3x cube plus 7x. It's not a factor of 3x cube plus 7x.